This recording will be devoted to an interesting example. What we have here is a block that's free to slide down an incline. Okay, we are given the gravitational force acting on the block. Fg is equal to 100 newtons. We are given the friction force acting on the block as it is sliding down. We are given the displacement d of the block, 10 meters down the incline. And we are told, corresponding to the displacement, this is the vertical drop of the block. L is 3 meters. It is asking us to draw the component of the gravitational force parallel to the displacement d. Consider this. Why is the block going to slide? It is going to slide because part of the gravitational force is pulling it down the incline. So how is the gravitational force acting? It's acting two ways on the block. It's acting perpendicular to the incline, and it is acting parallel to the incline. Now, perpendicular to the incline, it is just pushing it down the incline. So this is Fg perpendicular. And parallel to the incline, that's what's going to be responsible, along with the friction force, for the acceleration of the block, for the value of the acceleration of the block. This would be Fg parallel. So Fg parallel is parallel to d. Now the next question is to draw not F parallel, but draw how much of d is parallel to Fg. Now, if you think about it, when we go along this displacement, we are both moving down and moving horizontally. We are both moving down and moving horizontally. When we go down a ramp like that, down an incline like that. So, how much of d is parallel to Fg? This is how much down we are moving. This is d parallel. That's what's parallel to Fg. Now this is what's perpendicular to Fg. That's how much horizontally we move. So because of this displacement at an angle, it's made up of two displacements, a vertical displacement and a horizontal displacement. The vertical displacement is parallel to Fg. Let's go to the next question where it gets a little easier. What is the work done by the normal force as the block slides down the incline? Remember, what's the direction of the normal force? The direction of the normal force is perpendicular to the surface. Since it's perpendicular to the surface, it's perpendicular to d, so the work due to the normal force is going to be just 0. Now, okay, let's go to the next question. Find the work done by the friction force as the block slides down the incline. Now the friction force is going to be parallel the surface, since it is sliding friction, since my object is moving, so it must be sliding friction. So that's the direction of my friction force. Parallel to the incline, but opposite to the displacement. So that's the direction of my friction force. This is the direction of my displacement. They are opposite in direction, so the work due to friction is opposite in direction to d, so it's minus 30 newtons times 10 meters. So in this case, that would be minus 300 joules. Now the fun part. What's the work done by the gravitational force? Okay, and that's why we are working this example, just to illustrate that. We worked a previous example where gravity didn't do any work when we were pulling an incline sideways. I mean, not an incline, a block sideways. We also worked an example where we are lifting an object up or taking it down, dropping it, and we figured out the work done by gravity. In one case it was positive, in the other case it was negative. Now here, to find the work due to gravity, we have our pick. Now, we can look at it either way. We can look at Fg parallel and d, so then we say the work due to Fg is going to be Fg parallel times d, which is in this case, we don't know what FG parallel is, so don't know. But if it was given in the question, then we can find it. Now, our other option is think of the full FG. It displaced the object by this vertical amount. So then we write the equation as Fg times d parallel. Now these are parallel to each other. Then my equation becomes 100 newtons. They are in the same direction, so it's plus, times, what's d parallel? D parallel is the same as L. Look at them. So it's times 3 meters. So in this case, that would be 300 joules. Now, if I really wanted to find what Fg parallel, we can find it by writing this equal to 300 joules. We know what D is, so we can find Fg parallel. And you guessed it, Fg parallel in this case is going to be equal to minus 30 newtons. So it's actually my block, the fact that the sum of all works add up to 0 tells me that my net work is 0 and my net force is 0. So my block is moving down at a constant velocity. Okay, this is probably as tricky as it can get, but I think we addressed most of the points dealing with work here. In the next recording, we'll talk about power.